So we'll give it a quick second before we get started. All right, awesome. I see the numbers start to level out a bit, but hopefully some more students pop in soon. So my name is Ariana Lifshitz. I'm one of the counselors in the admissions office at RPI, and I just want to thank you all for attending our virtual architecture open house today. We have lots of different sessions going on. I know some of you are participating in portfolio reviews as well, so we're excited for those. I know that you're familiar with the platform already. You did just come from the first session, but just as a reminder, Chrome and Firefox are the two best browsers to use for this webinar. And if there's any technological glitches or anything, feel free to just refresh and that should solve them. So I'm going to turn it over to Mei-Ling Loco, the director of the Building Science program. If you have any questions in the chat or any questions in the meantime, feel free to type them in the chat. If they are related to the Building Sciences program, we'll save them until the end. So I'll turn it over to you.
Hi, everyone. Good evening. Hopefully you guys are still alive and awake on Sunday evening. But I'd like to tell you a little bit about the Building Sciences program, which is a smaller program, an undergraduate program, a Bachelor's of Science within the School of Architecture. And it is a really unique Building Sciences program for different reasons. It's something that is sort of emerging out of a number of crises in terms of energy, food, biodiversity. And at RPI, we're trying to respond to that in a very creative way and in a way that is led by design. So I'd like to just sort of define for those of you who may not know what building sciences are, what this discipline is. And this has changed quite rapidly in the last 10 years. When I first came to know about building sciences, it was about a decade ago. And at the time, it was defined as the collection of knowledge that focuses on the physical phenomena affecting buildings. So it's a lot to do with building physics, heat and moisture transfer. But you can imagine we have many other sciences today that are incredibly important in the way buildings work, in the way we live healthily in buildings where we spend an increasing amount of our time. And so that has evolved today, and it's still evolving, but it has now emerged to encompass a multi-scalar understanding of materials, products, how these products come together, and how the whole building system performs. It also looks at those of us who live in buildings in terms of our patterns of occupation, our health, our well-being, how our buildings and the activities that we do in our buildings affect our environment, as well as the practices that are needed to understand and predict performance within buildings. This is incredibly exciting for many reasons. It is almost as if the outside world is driving the study of buildings in this way. So in this sense, it's incredibly impact driven. We know today that buildings consume the largest amount of energy worldwide, ahead of transport, ahead of industry. So there's a huge quantitative reason to look at building and the building material life cycle as a site for driving impact. The second is we spend over 90% of our time indoors. Today, probably close to 100, right? And so this huge ability of the building environment to impact our quality of life is key. And lastly, every single material that comes into our building forms part of a much larger economy, a material economy, which are extracted from far away places and spend an increasing amount of times being transported to building sites where they spend decreasing amounts of time. So our buildings don't last as long, but their impact in terms of extracting materials, processing them, and transferring them into shelter is incredibly large. And so for these, quantitative and qualitative reasons, we find that the building sciences are an incredibly exciting place for anyone coming to the field of design and architecture to engage with. And so you'll come across many terms in the building science studios. For instance, material lifecycle design, which sort of takes on a very different view to the way we process materials for the use in buildings. Today, we take materials, we make them, and then we waste. And something that we're trying to do is evolve this concept of waste to eliminate waste and think about making, remaking, transforming, restoring. And so that's proposing a very, very different type of concept of material life cycle design. Another interesting topic that you guys will undoubtedly hear about in relation to the COVID crisis is the change in indoor air quality. And today, when you look at buildings, we are sitting in sort of a world that sort of prioritizes decreasing the exchange of fresh air from the outside. Why? Because when we bring in fresh air, it brings with us so many loads in terms of moisture and heat that our air conditioning, heating systems all have to condition, and they use energy. We can't afford to do that anymore with COVID. And we've got to bring in fresh air in specific quantities and make sure that it's treated in specific ways. And we also have to make sure we don't kill all the good with the bad, because that in the end affects also our health and well-being. So these are cutting edge topics that designers now have to engage with in a much more serious and critical way. And we think at RPI, given the focus on sustainability and a huge sort of technological and interdisciplinary setting, that this puts our program in a very unique position. Today, if you look at building sciences programs around the country, you will find, if you did do a search, that all these schools are sort of biased between something focused on construction technologies as well as sustainability. And at RPI, we consider ourselves right in the middle of both of these fields. We do not privilege another, although we have a stronghold in sustainability. And above this, it is not just the how in terms of construction technologies and sustainability approaches, but we're always considering the why. Why do these things? And this is embodied in this concept, this mission of generative citizenship, which, if you consider it in terms of the world we live today, it's really an environmental, an economic, and a social, political proposition where we view design and the role of designers as activists. So people who come from this field with this mission help to create value, often from places and from things that are quite invisible or not necessarily widely recognized, and help to translate that value and circulate it within a wide range of stakeholders in the built environment. This means we work with product designers, we work with engineers, we work with scientists, all to come up with new innovations in order to essentially create value for the wider community. And this why is an incredible source of inspiration for all of our studios. There is not a single studio you'll encounter in the building science program that isn't led by this generative citizenship mission. And for us, it's incredibly important that we begin from the standpoint of a designer. RPI's Building Sciences program is only one of two programs that is hosted within a School of Architecture. And we believe this is incredibly important because there are many skills that one develops as designers that enable us to engage in a multi-scalar and a multidisciplinary way with other stakeholders shaping the built environment. A good example of this is in our Capstone Studio, which is basically a joint studio with an upper level vertical studio in the Bachelor's of Architecture program, where we work with local organizations, the Troy Community Land Bank that owns a lot of deserted buildings or foreclosed buildings in downtown Troy, Habitat for Humanity, the Capital District branch, as well as TAP Inc. that has been instrumental in transforming a number of properties over the last 50 years in Troy, where RPI is. And so working with these three partners, we've identified buildings in our community that could either be retrofit or could be, to some extent, demolished and reconstructed and create sort of a whole wide range of programs, including affordable houses, in a very systematic way. So we're developing economic models, building technology models, financing models with our partners. This semester, for instance, we were working on this project where we took over a house that essentially had been owned by a wonderful nonprofit organization in North Troy called Nature Lab. And we were developing different programs where we could engage the community, so a huge community program, as well as provide affordable housing. And our students essentially get to use the city as an urban ecological campus, taking all sorts of data that impact the way we design. One good example of this is looking at, for instance, the impact of noise on our health and well-being, especially in downtown Troy. We think of noise in a very abstract way, but there are very important ways that we can quantify it that impact our health and well-being. And coming up with ways of remediating that noise or stress caused from noise in our designs.
One of the goals today is to talk through
the concept also of generative citizenship means that we're engaging people who are doing this work in the field. A lot of these sciences have only emerged in the last 5 to 10 years. So for instance, we're working with a wonderful designer from Google Sidewalks Labs, who just gave a lecture last month on the work that she's doing, essentially data mining in our cities, where one begins to think about designing spatially, not just from the vantage point of the building, but of the city. And we're not necessarily limited to sections and plans, but a much wider and multidimensional space canvas when we look at urban landscapes. Another example of generative citizenship is working with someone who's working at the interface of design and food, and trying to understand how do we rethink the building material life cycles within other life cycles, including food and waste within our cities. A previous graduate from RPI School of Architecture was also part of this talk just last week, and really embodies this new model of entrepreneurship that is rooted in generative citizenship by essentially thinking about during the COVID crisis, collecting compost waste in New York City when the city's compost program was suspended, and distributing that compost to the farms, where essentially all of this surplus resources, because a lot of farms could not distribute this to grocery stores, to restaurants that were closed over the past 6 to 8 months, and essentially delivering that to people whose compost she has just, her company has just collected. So this really interesting business model that was recognized in this composting gap over the COVID period was another form of generative citizenship. And a lot of her design knowledge about mapping the city, about understanding how to program collection and allocate resources in real time was important for this. Next month, a really interesting, another generative citizenship talk looks at new forms of urban data visualization and storytelling. And we're going to be working with Ainsley Robson, who will also run a workshop next year in our program, which enables our students to use a lot of the tools. This, for instance, is called photogrammetry, but using photographic data from our cities, and actually embedding them with knowledge, including heat, moisture, air pollution, all of these different data sets that can essentially make our cities come to life in terms of understanding what's happening within them. So the curriculum model in the program is incredibly interdisciplinary. It's a 130-degree credit program, and I see some questions about transfer credits, which I'm sure Ariana or myself can answer at the very end. But essentially, we have 4 years where we have a mandatory spring away. We don't have the option in the BARC program of taking the fall or spring away. And this is because we have a core set of studios that are essentially run in the fall semesters as a vertical. We have a really important balance of environmental and construction technology courses that address a lot of the fundamentals that you find in the wider building science field. We also have separate studios and construction industry seminars that expose us to a lot of the people that I was sort of describing in terms of 21st century building sciences. And just to take you through sort of the conceptual framework for the studios, I'll just talk about, the studios moving from first year all the way to Capstone in the fourth year. But essentially, the first year is about understanding how to essentially see the building and our environment as a rich, abundant data landscape. And this starts from the scale of an object before we start to analyze buildings in this way. In the second and third year, you are sort of in what we call building sciences performance studios, where we begin to contextualize, spatialize data. And these are a diverse set of data sets, including urban air quality, building height that may be linked to social isolation. It could be acoustic data, lighting data in our cities at night. But you learn how to contextualize and organize these data sets, some of which are digital, some of which are also measured. So there's a huge field-based component to this. And lastly, in the fourth year, we have the Lifecycle Capstone Studio, which is essentially a design build studio working with stakeholders in the city of Troy that I just described before, where one actually begins to take what you've learned in the classroom and actually apply them in a real world scenario through a design build retrofit project. So, for instance, in the first year studio, when I said we're working at an object scale, students actually engage with what we call a toaster exercise, where one actually measures all of the physics, the chemistry going on in the process of toasting a piece of bread, and relating that, visualizing that data as the temperature in the toaster, as energy is transferred from mechanical to heat energy. And this type of concept of understanding this piece of bread as an object within an energetic system is something that gets applied to understanding case studies in the built environment. So for instance, the student who was very interested in the taste and the smells, the chemicals that are produced in the process of toasting, applied this to study a building in Switzerland, which was very interesting in terms of its energetic formations as it was being constructed. And so using climate data, what you see over here is what we call a climate clock, taking solar data, moisture data, temperature data, and showing how across seasons, different smells, aromatic compounds are produced through the interaction of moving through this building and the climate that is beginning to regulate what's outside of the building. And so being able to be incredibly adaptive and creative in visualizing all of this information on the scale of a building is incredibly important. In the second and third year studios, working at the scale of a home, we actually begin to understand and how to simulate and study the performance of buildings. So, this year's studio, for instance, focused on passive house, which is essentially a way of improving the thermal and the energy performance of a building by designing it to be incredibly high performance. So a lot of things like insulation, energy efficiency in terms of heating, ventilation, and air conditioning systems are something that you focus on. And you become exposed to a lot of tools that are incredibly important in the industry today in terms of environmental performance. So everything from understanding how to calculate the embodied energy of the building materials systems that you use, to how your facade may respond to the sun, or how a facade or a glazing system may affect the daylight quality inside of your building, are things that you begin to learn how to quantitatively estimate and predict through using specific tools. In the last studio, your Capstone Studio, building science students working with architecture students develop multiple proposals where one concept that a building science student is developing or researching has to be applied multiple times to different proposals. And this idea that there is no one solution that fits all, that there are many ways to achieve a specific type of importance, is the rationale behind this. So for instance, these students who were looking at the impact of creating essentially a buffer layer, sort of a greenhouse on the periphery of a residential unit, and how that may lead to really interesting dynamic thermal occupations of the floor, is something they did in 3 proposals that you see over here. Another student started studying daylighting, for instance, using different glazing materials and evaluating the cost and embodied energy of these materials across the same proposals. But a lot of these specific research topics are developed in accordance with very individualized interests that are amplified by their ability to concentrate in another discipline. So students in the building science program typically have a concentration. Most of our students concentrate in sustainability, lighting, acoustics. Business is a growing one, civil engineering is another. But they basically take that concentration and define a much deeper path of inquiry in their capstone project with the Capstone Studio. Our students who graduate from the building science program go on to work in a much broad array of jobs than you'll find from the Bachelor's of Architecture program. And these also sort of focus on sustainability and social justice in a huge way. So for instance, a lot of our students go to work in large architecture and engineering firms like Arup, EYP, Payette, RDH, AECOM, all of these firms that require a high performance group, people who actually are design partners in sustainability or environmentally important aspects of projects. So you can also go into an architecture and engineering firms with a building science career, but you might have a more definitive or specialized role in terms of working with the environmental team or the high performance group within an architecture and engineering firm. But more and more, we're seeing our students also going into proactive organizations. So students are interested in working with new types of material programs, for instance, the Living Building Challenge, which is essentially LEED on steroids in terms of certifying and driving the types of criteria that we expect our buildings to perform to today. A lot of students go the entrepreneurship route and work with startup companies that are really developing really interesting materials in our buildings. A student of ours who graduated 2 years ago is sort of the lead designer at Ecovative, which is a company that grows materials out of mushrooms to serve as insulation and alternatives for styrofoam or plywood products in buildings. Two of our students last year, whose work you just saw, work at Arup in lighting, for instance. The other works in sort of the high performance group at AECOM. So all of them have begun to sort of develop a niche within these firms. Some students may decide actually they would like to stay and specialize in a graduate degree program. So with a building science degree, and this is quite common, students tend to stay to do a 1-year Master's of Science degree, either in lighting, acoustics, or CASE, which is our Center for Architecture, Science, and Ecology that is based down in Brooklyn, an industry city that focuses on sustainability. And we have a very strong link with CASE in terms of research and sort of focus in terms of sustainability. Two of our students this year are going to go on to actually going back into architecture to do a 2-year accelerated MArch program, because they realized with these specialized knowledge in terms of building sciences, this would accelerate their path in terms of working in an architecture firm further down the road. So these are just a few pathways in terms of staying in academia after graduating the Bachelor's of Science degree. But more and more, I think some of these jobs essentially were not even created by the time students joined as freshmen. But by the time they graduate, there's a whole host of new jobs from Google Sidewalk Labs, from IDEO, that are recruiting designers who are able to think about buildings and work with data in this type of way. So I'll probably just stop there and look at this whole stream of questions that are coming in, and I'll start at the top. Okay, Ariana's taken Ben's question. Justin's question: what is the building sciences program looking for in a portfolio as opposed to the BR program is looking for? So our modes of representation and digital skills are quite different in the building sciences program. What we're interested in is an ability to sort of graphically communicate phenomena that you observe. So anything from sketching, from being able to take physical measurements, maybe even an exposure in a robotics program in your school or through a computer-aided design course in your school. These are all great things to serve as a foundation coming to the Bachelor's of Sciences program. We also look at sort of the quantitative performance in terms of physics, chemistry, biology. Those count a lot in terms of what we consider as a good foundation coming to the program. Although we encourage our students to take specific science elective courses, coming in with that background is incredibly important. Before this year, a portfolio for the Building Sciences program was not required, and it will be required for next year due to the shift in the program's identity. But any information on that will be sent via our admissions department, and it will be updated on our website in the spring. Are your dorms HVAC graded? Maybe Ariana can answer that later. I think they are. I know the School of Architecture's HVAC system is upgraded. What type of jobs? Andrew, I hope I answered that question in terms of describing some of these, that, you know, the kind of firms that our recent graduates work at now. You know, RDH is probably the world's leading building science and engineering firm that's based in Canada and Boston and is only growing. EYP is all over the United States. Arup is global. So is AECOM. AECOM is the second largest architecture and engineering firm. So there's a wide array of sort of leading firms that our students go into. But again, there are niche applications in terms of entrepreneurship and sort of other companies that are working at the proactive end of sustainability. So there is also, I guess, I haven't put this here, but I guess in terms of urban data sciences, a lot of the work coming out of Google Sidewalks Labs, IDEO, WeWork before it collapsed, are also looking for this generation of designers, of building scientists. So that's an area we expect this green collar industry to grow in the near future. How common or feasible is it for a student to enter in the building sciences program and then transfer to the BArch program? That's not very common. It does actually happen the other way around. But, you know, I do think in the first year, you know, especially in the first semester, you know, it's important to sort of gain enough exposure within the program you're accepted into and figure out a good fit for what you're truly interested in. But, you know, the identity of the building science program is quite distinct based on what I've sort of described. Our studio culture is quite different. Our mission is quite heavily focused on this generative citizenship mission. Our skills in terms of digital constructs and building sciences media engage much more with data. And there's much more analysis and evaluation of buildings and designing with data. So it is quite a substantially different program. And this is not a professional program. This is a Bachelor's of Science. So I think, you know, if during the course of your RPI career, especially in the first year, you think that the BArch program is where you belong, that's definitely possible. I do think that there are opportunities for collaboration through the joint studios. So yeah, I think that there are places where the programs intersect, but transferring something is something we try to make sure we advise students on very carefully in the first year. Is there a way to dual in both BArch? This is the million-dollar question, you know. We've been trying, this was actually something one could do up until the 1990s, but because the BArch program is NAB accredited, there was a restriction placed on being able to dual between BArch and building science. So unfortunately, that is not possible anymore. Yeah, unfortunately. In terms of having one as the major or minor, that is also not possible anymore. Do you have to be strong in maths? I mean, it is helpful, but you do have 2 core math electives that we require all of our students to do, and that is more than sufficient to deal with the content in the building science program. So, yeah. Any other questions? Oh, 6:30, I know there's a portfolio review coming next. But if anyone has any questions and concerns in terms of application requirements, please feel free to reach out to me at locom2@rpi.edu. My email and all my contact information is also on the RPI Architecture website. I'm more than happy to talk to you individually and discover if this is the right fit for you. But again, there's a lot of updated information coming on the fall 2021 building science program. There are a few changes that are happening that are incredibly exciting. So I would encourage you to check back on the website early in the spring when all of those changes are published in our catalog. Thank you, everyone. And enjoy the portfolio reviews and the rest of the breakout sessions. Ariana, I don't know if you're still there. I know it's supposed to end right now, but if there's anyone who wants to hang out and even ask more specific questions, I'm happy to stick around for a few minutes to answer questions. Okay, I see some questions here. Sarah, could you minor in building science with an architecture major? Unfortunately not. Can you wait until the end of your freshman to decide your major? Well, you do come in with a certain major. You come into that program. But I've advised students who've switched into building sciences at the end of their first year or at the beginning of their second year. So that is possible, but we suggest you work very closely and stay in contact with your advisor to decide, whether, you are in a program that you're truly passionate and care about and the content is exciting to you. So that is possible, but you will have to come in with a certain major because all of your classes are designed in that way. Unfortunately, Jackson, a lot of the building science first semester courses, as well as some of the second semester courses, count for both building sciences and architecture. So in terms of that switch, you don't lose a lot of ground because, a lot of the fundamental courses have overlap. How many students are in the program? We have a very small program. We do not accept more than 12 students a year. And we have very intimate studios. Second and third year studios will be taught as verticals, so they're quite large. And Capstone Studio is a mix of BARC and building science studios. So that's a normal studio size of 12 again. So the student to faculty ratio in the building science program is really small, so you have a lot of attention and time. This also increases your opportunities of doing undergraduate research and independent study with faculty, not just within the building science program, but in another discipline, for instance. So we consider that a huge asset of the program. All right. I think I've answered all the questions. If anyone has any other, please feel free to shoot me an email. Okay, take care, everybody.